Hi guys, it's Mrs. Raposa again, and I'm going to be going over limit laws of composite functions. I'm on page 10 in your note packet. And we've done limit laws, but we just haven't done limit laws of a composite function. And a composite function is something like f of g of x. Well, what it says is if the limits as x approaches a of f of x and the limit as x approaches a of g of x exist, then the limit as x approaches a of f of g of x, we can rewrite like this. F of the limit as x approaches a of g of x, but we can only do that if the limit as x approaches a of g of x is L, and if f of x is continuous at L. So that's a lot. The main idea behind this is if ever you see a composite function like I have here, the limit as x approaches a of f of g of x, we pretty much want to start automatically by rewriting that, by pulling the f out front and keeping the limit as x approaches a right here, but it's of g of x. So that f came out front and it becomes f of whatever value we get in here. So this only works though if there are certain conditions that are met. That as we go through problem 1, we'll talk about the conditions. So problem number 1 says, find the limit as x approaches 0 of f of h of x. So let's rewrite it. Let's pull that f on the outside. So we're going to say equals. We'll pull the f on the outside. On the inside, we're going to put lim as x approaches 0 of h of x. Okay, let's evaluate the inside first. So the limit as x approaches 0 of h of x. Let's come over to our h graph, and the limit as x approaches 0 is down here at -1. So we can replace that with -1. Now the question's asking for f of -1. But we have a problem. Because if I look at my graph of f at -1, I see this asymptote. So we can only use this method that we have written out, that I have written out in red, if the function f is continuous at -1, and it's not. So because it's not, we actually can't do that. We'll write it, but then we'll cross it out. And instead, we will rewrite this line as the limit as x approaches -1 of f of x. So instead of f of -1, we rewrite it as a limit. But when we rewrite it as a limit, we actually have to figure out whether it's going to be a one-sided limit, whether it's going to be a left or a right limit. To decide what to put there, we come back to this limit. And we come back and say when we did that limit, the limit as x approaches 0 of h of x, we came in from the left, we came in from the right, and we got the number -1. Well, how did we get -1? Like, where did we come from? Well, when we got -1, we came from above. Okay, so we have to ask ourselves, where did we get -1? We got -1 by coming from above -1 to get there. And so because we came from above, we put a little plus sign there. Okay, and we'll do plenty of examples, but it's a one-sided limit, and I put a plus sign there because when I found my original limit, I came from above. So now let's find this answer. So this one says, find the limit as x approaches -1 from the right side of f of x. So from the right side, I'm going up and up and up and up and up all the way to infinity. And so my final answer here would be infinity. Okay, seems a little strange at first, but as we go through examples, hopefully you become more comfortable with it. So let's try problem 2. Problem 2, again, is a composite limit. So it says the limit as x approaches -1 of f of x. So immediately I'm going to rewrite this. I'm going to pull the f out front, and then inside I'm going to put lim as x approaches -1 of f of x. And let's see what we get. F of, well, the limit as x approaches -1, coming from the left, coming from the right, say, what would my limit be? And my limit would be the number 2. So I put the number 2 in there. And then the question becomes, what is f of 2? Okay, now this only works, though, if this is continuous. And f is not continuous at 2. So if we look at my graph, I'm not continuous at 2. So if I'm not continuous to 2, at 2, I cannot do that. I have to put an x through it. And instead, I rewrite this as the limit as x approaches 2 of f of x. But I need to figure out whether I'm going to be doing a left-hand limit or a right-hand limit. So to determine left or right, I go back to my first limit that I found, this inside piece. And I said, when I found the limit as x approaches -1, my answer was 2, but I was coming from below 2 to get there. So because I was coming from below 2, this is going to be a minus. Below means I'm going to be doing a left-hand limit. And so let's try to evaluate our new problem here. Below means it's going to be left. And so if I'm looking for now the limit as x approaches 2 coming from the left. Well, here's 2. Coming from the left, I am up at 5. So my answer is going to be 5. So this limit law that I showed only works if f of that value is continuous, or if the function f is continuous at that value, and it's not. So at the bottom, I have problems 3, 4, and 5 that are going to use the graph of f and the graph of g. Okay, so we have to keep track which graph is which. So problem number 3. Immediately, I'm going to rewrite this as f on the outside, lim as x approaches 1 of g of x goes on the inside. Let's find that limit on the inside. The limit as x approaches 1 of g of x, that's over here. The limit as x approaches 1 of g of x is 0. So I can put a 0 there. Then I find f of 0. Now let's come on our graph of f, and this is really nice because f of 0, this happens to be continuous. So I don't need to do anything fancy here. I just need to tell what the answer to f of 0 is. Because it's continuous, I can just go ahead and say f of 0 is 2. And that's my answer. It's only when it's discontinuous there do we have to do a little extra work. I'm not going to do number 4 only because number 4 was just on the test, or very similar to the test that you just took. That is not a composite limit. So I'm going to jump over to number 5. On number 5, it's f of x. So I'm going to pull the f on the outside, and I'm going to put the limit as x approaches 0 of f of x right here. All right, let's evaluate the inside. So on the inside, the limit as x approaches 0 of f of x. We're up here. And it's 2. Okay, then I say, okay, f of 2. So I'm really only focused on this graph over here. That's the graph of f. We have a problem. F of 2 is discontinuous. So I can't do that. So I put an x through it for my notation. And instead, I rewrite this. Instead, I rewrite this as the limit as x approaches 2 of f of x. We just have to decide if we are going to do this as a left-hand limit or a right-hand limit. So to figure that out, we go back to that original inside limit and we see how do we find that. Well, let's look. As x approaches 0 of f of x, I'm going to look at what I just highlighted, and I'm coming from below. I got the value of 2, but I'm coming from below. And so because I'm coming from below, this becomes a left-hand limit. Below becomes a left-hand limit. above would become a right-hand limit. And so the limit as x approaches 2 from the left. Let's look at my graph. Here's 2. Coming in from the left, my answer is 0. Okay. All right. Flip your paper over, and we're not going to do all of them on this back page, but we are going to try number 7, 8, and 9 here. And I would love it if you paused the video and gave these a try. Pause the video and give them a try. And if you're getting stuck, you can come and look at my work. Okay. So if you have unpaused your video, go ahead and take a look at the values that I've put on here. The number 7 worked out nicely because number 7 was continuous at 2. G of 2 was continuous. We could do that. But number 8 and 9 did not work because G of 1 was discontinuous. So you had to rewrite that as a limit. And just check all of your answers here. And I got 1 for problem number 7, -1 for problem 8, and 0 for problem 9. So we'll take questions on this during class, but hopefully you followed along and filled in your notes.